Hi everyone! In this video I'd like to continue solving some exponential and log equations, and I want to get into a little bit messier equations where we'll have to use some of our log properties to help us solve. So we want to be really careful with some of these. Otherwise, our basic strategy is the same. If we're trying to solve a log equation, we would like to at some point exponentiate to get rid of the log. If we're trying to solve an exponential equation, we would like to at some point introduce a log to help us get variables out of exponents. So on this first one, this is looking really promising. They're all log base 3s, so exponentiating with base 3 should help me cancel, but I need you to be extremely careful when you do this. If you exponentiate right off the bat, what you'd really get is 3 to the log base 3 of x plus log base 3 of 2 equals 3 to the log base 3 of 3x minus 1. Things work out beautifully over here. 3 to the log base 3 of 3x minus 1 is just 3x minus 1, but you have to be very, very careful with the left-hand side. You cannot distribute the base of an exponential statement. So here, if we think about our order, when we plug x in, we would take a log, we would then add, we would then exponentiate. So the taking the log and the exponentiating don't happen one right after the other, which means they won't cancel out. So before this will cancel, and in fact generally I do it as my first step, but we'll go ahead and do it now. You would have to combine the logs. The log base 3 of x plus the log base 3 of 2 is the same as the log base 3 of 2x. So the property that says if you're adding two logs you can combine it into a single log is ideal here. Now we have inverses happening one right after the other. So we plug in an x, we double it, we take the log, we then exponentiate because that happened one right after the other. That will cancel. I then need to subtract 3x from both sides. So I get negative x equals negative 1, which means x is equal to positive 1. There's a non-optional check here. This is a log equation. Log of 1, totally valid. Log of 2 is good. Here, if we plug in 1, we get the log of 3 minus 1. The log of 2, again, totally valid. So that's looking good. And once again, if you want to do a more thorough check, you can. We got the log of 1 plus the, log base 3 of 1 plus log base 3 of 2 equals log base 3 of 2, which sounds a little questionable until you think about the fact that the log base 3 of 1 is 0. So it really is a good statement. Log base 3 of 2 equals log base 3 of 2. Okay, number 2 is similar, but this time we have a difference, so we're going to have to be a little careful. I'm going to go ahead and use my log properties first here. I am still thinking that I want to exponentiate with base 5 to get rid of the logs, but I know in advance the same thing that held over here will be true here. I need to combine those logs before I'm going to be able to eliminate them. If you're subtracting two logs, this is going to be combined into the log of a quotient. Okay, now I can exponentiate with a base of 5. So I'm thinking 5 to the log base 5 of x over x plus 1 equals 5 to the log base 5 of negative 2x. Ignore that. The 5s and the log base 5s both happen one right after the other, so we can cancel all of that extra mess and just say x over x plus 1 is going to equal negative 2x. We have now successfully converted this log equation into a rational equation. If we want to solve this thing, we're going to multiply both sides by an x plus 1. Get the variables out of the denominator. I'm going to go ahead and distribute. I wouldn't want to divide here because there's an x involved. I could lose a solution. So I'm going to say x equals negative 2x squared minus 2x. And then I think I'll move everything to the left. So let's add the 2x squared and add the 2x. Add the 2x. So we end up with 3x. We can factor an x out. And it looks like we're getting x equals 0, or what is that going to be? X equals negative 3 over 2. We have our non-optional check. X equals 0, not going to work for the first one or the last one, so we should throw that away. If it doesn't work for any log in your original equation, you have to throw it out. X equals -3/2 actually also doesn't work. It doesn't work for the first one. It doesn't work for the second one. It would work for the third one, but it doesn't matter. So this is actually a no solution. And that's completely valid. That can happen. If you get two solutions, they might both work. One might work. Neither one might work. All of those things are possible. So just make sure you check anytime you start with logs. Okay, so if you end up with too much log mess floating around, remember you can always combine logs using the sum and difference properties, and that's a good thing to do before you exponentiate. Having an addition or subtraction in your equation is kind of your enemy when you're working with exponential or log, really. Neither one of those is particularly nice when you have addition subtraction. Okay, this third one is exponential, not log. And the reason this one is showing up on the tricky day is because both sides have a variable stuck in the exponent and they do not have the same base. Not only do they have the same base, there isn't a base that will easily wipe out both of them. So you just have to try and choose the most efficient way to go about this. And I would say your most efficient way is to cancel out one or the other. Can't be both, but you can cancel out one of them. So I'm going to go ahead and choose, I don't know if it matters, we'll choose a log base 3. So I take the log base 3 of both sides. And there isn't a wrong choice here. Log base 4 will also make your life fairly easy. A natural log would work just as well here. It'll just be slightly messier. So I think it's a good choice to use 3 or 4, but any log will work. The left-hand side works out really nicely. Log base 3 of 3 to the x plus 1 is just an x plus 1. The right-hand side isn't as nice, but we still make some progress. Even though the log base 3 doesn't cancel out the exponential base 4, we do have the power property that allows us to drop that down to the front. So 3 minus 2x times the log base 3 of 4. The parentheses are really important here. Basically having all of that up in the exponent grouped it together, and when we move it down to the front, the 3 has to get multiplied by the log as well as the negative 2x. That was all power, so it should all be part of this product. And that's actually the next thing I need to deal with. Those parentheses are trouble. I'm trying to solve for x. I've successfully gotten all of the x's out of the exponent, but now I have one stuck in parentheses. I would not choose to divide here because that will stick an x in a fraction, which would be something that I'd want to deal with just as much as having x stuck in a parenthesis. So distribute. Looks a little messy, but the log base 3 of 4 is just a number that you're multiplying a difference by. So you can distribute it through and say I have 3 times log base 3 of 4 minus 2x times log base 3 of 4. I'm trying to solve for x, sorry for the wiggle, so I think the next thing I need to do here is get x's on one side, and it doesn't really matter which side. I'm going to choose to move x's to the left so that I have fewer negative signs floating around. As soon as I choose to do that, I also will move the 1 to the right. So basically any term with an x gets moved to the left, any term without an x gets moved to the right. So this is headed that way, and this is headed that way. Okay, so I'm adding, leave the x where it is, add a 2x log base 3 of 4. This will eliminate the negative 2x log base 3 of 4 on the right, and instead you'll have one on the left. I'm going to leave the 3 times log base 3 of 4 on the right. I'm going to subtract 1, which will eliminate it from the left, move it to the right. Once again, make sure you don't try and subtract the 1 from the 4. Not good order of operations there. You'd have to take the log and multiply before you could do any subtraction. This is a step that a lot of people will get stuck on. I got x on one side, but there are 2 of them, and I can't combine a 1x with a 2 log base 3 of 4 times x. However, this is kind of like literal equations. There is another trick you can use, and that trick is factoring. So really make a note of this. Make sure that you don't forget that when you're solving these and you get the messy coefficients involving logs, the way to isolate a single x is to factor it out and then divide. And this is a completely acceptable answer. There are things you could play around with. You could move the 3 up, you could move the 2 up. I don't care if you do any of those. If you can give me an exact answer, x is all by itself, I will be happy. So try to deal with things like fractions and fractions, but I have no problem getting a log in an answer like this. I do not want you on any step along the way here to switch to decimals. I want that exact answer. And to try and make this easier, because you do get to choose which log to use, on my answer key, what you'll see is log base b's. If you go ahead and replace the b with whichever base you used, you should be able to do a little bit of simplification and check and see if that really matches your answer. If you're having any trouble at all checking those, feel free to ask me. I don't mind helping you check your answers if you're confused at all about how to decide if you really got it right or not. Okay, back to a log equation. So here we have the log of x plus the log of x plus 21 is equal to 2. Once again here, the big thing going on is that we need to combine the logs before we try and cancel them out. You cannot cancel out when there's a sum over here. So I'm going to go ahead and use the property that says you can combine the sum of two logs into a single log. Now I'm ready to get rid of the logs. Because there's no base, I'm assuming this is a common log, log base 10, which means I want to exponentiate with a base of 10 to get rid of it. Okay, so 10 to the log of x times x plus 21. The 10 to the power of the log will cancel out, and I'm just left with the x times x plus 21. And then 10 squared is 100. Again, be really careful about what's going in the power here. Sometimes I'll get 2 to the 10th instead of 10 squared, and that is not good. That doesn't work. So really think about the exponentiating step, even if you don't write it for me. Okay, I've turned this into a quadratic. It's not really helpful, this kind of partial factored form. Factored forms are only helpful if this thing is equal to 0. So I'm going to go ahead and multiply that x back in, and then set this whole thing equal to 0, plus 21x minus 100. And I think, once again, I was nice to us. This is factorable. I know I'm not always that nice on your homework, so make sure that you remember that you can use a quadratic formula if needed. But here, it looks like if I use a 25 times 4 to get the 100, I'll also be able to get the sum of 21x. So positive 25x minus 4x is 21x. Which means x can either equal negative 25 or positive 4. We do have to double check, non-optional check. This was a log equation. Unlike the last one, it was exponential, so we didn't have the non-optional check. Negative 25 is looking like bad news right off the bat, so I'm going to throw that away. 4 is looking great. I can take the log of 4. I can take the log of 25. So x equals 4 is my one and only solution. Okay, I think I have one more for this video. Oh, I have 3 more for this video. So I think I've actually gotten the gist of it down already. I would say from here on, I'm going to do more, but in class, I would have you guys try these on your own, and then we check back in together. So this would be a great time to pause and try and work ahead of me and replay and check the answer, see if you got it or not. All right, so natural log of x equals 1 plus the natural log of x minus 1. This one's actually really similar to the last one, but some people will get stuck right off the bat just because you can't combine the 1 and the natural log on this side. And as I've mentioned, the addition is kind of your enemy when you're trying to exponentiate. So really the trick here is just to move the logs to one side first so that you can combine them. So I'm going to start by subtracting the natural log of x minus 1. Now that I have the difference of two logs, I can make that natural log of x over x minus 1. Finally, I'm ready to exponentiate here. I don't have anything but a log on this side, so if I exponentiate with a base of e, it will cancel that out nicely. Again, remember that you're doing e to the 1, exponentiate base e, not 1 to the e. On the left, I'll be left with only the x over x minus 1. On the right, e to the 1 is just plain old e. Okay, so it's no longer a log equation. This is now rational. Even though that e might look kind of scary floating around, it's just the number 2.7-ish. So if I want to solve a rational equation, I want to focus on my x's. And I do have an x in the bottom, which means I'm going to go ahead and multiply both sides by x minus 1. I now have an x stuck in parentheses, so I'm going to distribute the e through the parentheses. I think I'm ready finally to get my x's on one side, so I'll subtract an ex. And then once again, I can't combine a 1x with an ex, so I'll factor. Which means I get a negative e over 1 minus e. This should have the non-optional check. So you can, as you're working through your homework, use a calculator to check, but just keep in mind that this is an exam that I won't let you use a calculator on. So we should be able to do sort of a rough check is what I will call it, an approximate check, just by saying, okay, this is in the ballpark of negative 2.7 over 1 minus 2.7, which is negative 2.7 over negative 1.7, which becomes positive. And it's what, a little bit less than 2. It's between 1 and 2. So the numerator of the fraction is bigger than the denominator, which means it's bigger than 1. 1.7 times 2 is a 3.4, so it's smaller than 2. So if we say, okay, I have an answer that's a little bit bigger than 1, it is perfectly legal to take the natural log of that number. It is also legal to take the natural log of that number minus 1. So recognizing that this is a little bigger than 1, really important. If this could possibly be smaller than 1, we'd get in trouble here. So it's looking good, and if you use a calculator to check, you should see that it is in fact good. But just to mention that for the no calculator thing, if you can kind of use that rough idea to decide, is this negative, is it 0, is it smaller than 1, that's good enough. Okay, next one, and once again, I would say great to go ahead and try and work through this one and then check the answer, and then if you get it wrong, you can come back and watch the video. So here, I'm going to go ahead and combine the two logs. I'd like to exponentiate to get rid of the log base 2's, but it won't just wipe out the log base 2's when there's an addition in the mix. So deal with the addition first. And I'm actually going to do one more step. I'm going to go ahead and multiply that quadratic out. It's fine if that doesn't happen right now, but I'm going to go for it. Okay, so I get an x squared plus 6x plus 8. I can now exponentiate with my base of 2. I'm just going to do it the lazy way instead of rewriting all of that. So now it's 2 to the log base 2 on both sides. Because the log base 2 is on both sides, this just cancels out completely. And I get x squared plus 6x plus 8 equals 3. So I once again turned a log equation into a quadratic equation. I'm now going to subtract 3 from both sides. That looks nicely factorable, x plus 5, x plus 1. Which means x could be negative 5 or negative 1. We'll have a non-optional check here. So if I plug the negative 5 in, the very first thing I get is a log of negative 1, so I can throw that away. You are not allowed to take the logs of negative numbers or 0. If I plug the -1 in, I get the log of 3, that's fine. I get the log of 1, also fine. So that one's looking good. And again, you can check a little more thoroughly if you'd like to make sure that it really is right. We get the log of 3, log base 2 of 3, plus the log base 2 of 1, which is 0. 2 to the 0 is 1. So basically, log base 2 of 3 equals log base 2 of 3. That looks fantastic. Okay, a last one, another one of these tricky exponential equations. So once again, pause, check your answer, watch if you don't get it right. Okay, so on this one, I'm going to go ahead and use a natural log. You can use any log you want. I would say natural log and log base 5 are your best two choices because they'll actually cancel something out for you. But really, any log you want is fine. And you'll end up with an x plus 4. On the right-hand side, you don't get the nice cancellation, but you do have the log property that allows you to bring down the exponent. So it's still an improvement. I've now got my x out of the exponent, so this is no longer an exponential equation. It's linear, but it doesn't look very nice having this natural log of 5 floating around. So I'm going to go ahead and distribute so that my x is not stuck in the parentheses. So I have a 2x natural log 5 minus a natural log 5. And then you want to move your x's to one side, your constants to the other side. What do I want to do here? I think I'm going to move the constants to the left and the x's to the right this time so that I have fewer negative signs. So I'm going to leave the 2x natural log 5 exactly where it is, and I'm going to leave the 4 exactly where it is. To move the x to the right, I'm going to subtract x from both sides. That will eliminate it on the left, and we'll have a minus x on the right. To move the natural log of 5 to the left, I'm going to go ahead and add it to both sides. That will eliminate it on the right. We'll have a plus ln 5 on the left. Okay, so x is on one side of the equation. That's really good if we're solving. This, once again, is a little tricky because you can't just add the 2 natural log 5 to the -1, but you can factor. And that would tell you that the coefficient that you should get for x is 1 less than 2 times the natural log of 5. And then your last step here would be to divide. So we get x equals 4 plus the natural log of 5 over 2 natural log 5 minus 1. Okay, if you chose to do this one with a base 5, it's going to look a little different, but it should still be good. Think about this. I can spot it right here. You would have the log base 5, I guess this is really right here, of e to the x plus 4 equals 2x minus 1. So the x plus 4 would move down to the front, and you'd have a log base 5 of e. If we then distribute, look like this. I'm going to choose the same side. I'm going to move x's to the right and leave constants on the left. So the 4 log base 5 of e stays where it is. I'm going to add 1 to that side. The 2x stays where it is, and I subtract the x log base 5 of e. I can then factor out the x. And divide. So I'll get the 4 log base 5 of e plus 1 over 2 minus log base 5 of e. Again, I have no preference between answers here. If you chose a different base entirely, that's fine as well. If you chose a different base entirely, you can try and get a decimal answer for that out of your calculator and check it against a decimal answer for one of these. But there's a couple of possible options. If you ever notice that all of your signs are swapped, so if you had gotten -4 minus natural log of 5 over 1 minus 2 natural log 5, that's actually a totally good sign. That means you chose to move things to the opposite side that I did, and your signs are all reversed because of that. But remember, you can always multiply top and bottom by -1, and it'll turn it right back into what I have up above. All right, thanks for watching.